The section we're going to work on today is 4.4, trigonometric functions, at any angle. The first objective we're going to cover is looking at the definitions. Now before we define these, I would like to go through some stuff we've already talked about. Number one, we've talked about the ratios for sine, cosine, tangent, cotangent, secant, and cosecant. We've also talked about from the center to an angle in standard position on our unit circle. Its values as sine is y, cosine x, tangent is y divided by cosine, or y divided by x. Well, now we're going to kind of combine the idea of both of them. We're going to be thinking of a point as some lengths, a vertical distance and a horizontal distance, and applying our sine, cosine, and tangent, SOHCAHTOA, to these points. So given a point, on a plane with an angle of theta in standard position, we have the length of a radius, r, which can be found using the Pythagorean theorem. The radius is represented as the hypotenuse on a right triangle. So the Pythagorean theorem for r is x squared plus y squared, and then we take the square root. So before I give the definitions, let's go ahead and look at an axis. Let's make it more straight than that. I have some point P out here. Its horizontal distance is x. The vertical distance is y. This is a right angle. And this is my value for r. We can use sine, cosine, and tangent, and opposite, adjacent, and hypotenuse to figure out some new definitions given a point at any angle. So let's come up with those definitions. For sine, we know it is opposite over hypotenuse. So let's look at our picture. This is my angle theta. Opposite is y. The hypotenuse is r. So therefore, sine is equal to y over r. Cosine. Cosine is adjacent over hypotenuse. Therefore, using our picture again, adjacent is x, The hypotenuse is r, so our ratio for the cosine would be x over r. Tangent. Tangent is opposite over adjacent. So opposite is y, adjacent is x, so y over x. Again, the special condition that x cannot be 0. Next, the reciprocal functions. The reciprocal function for sine is cosecant, and it's just the reciprocal of this, so it's going to be r over y. For cosine, it is secant, and the reciprocal of this is r over x. Lastly, the reciprocal for tangent is cotangent, and the reciprocal is x over y, with the special condition that y cannot equal 0 for cotangent, x cannot equal 0 for secant, and y cannot equal 0 for cosecant. Why? Because we can never divide by 0. So these values we already know, we're just looking at it from a different perspective. So let's do an example. Example 1, evaluate. Trig functions. So I'm going to have my point P is the point -3, -5. We want to find the 6 trig functions for theta. I'm going to go ahead and draw the picture and label it. -3, 5 is going to be in this bottom quadrant, somewhere out here. So in my triangle, this is -3. This down here is -5. I need to find the radius. So we do r equals the square root x squared plus y squared we get the square root of 9 plus 25, which is 34. Now that I have r, we can find our 6 trig ratios. I have an x, I have a y, and I have an r. So the first one is sine theta, y over r. We cannot have a square root in the denominator, so we rationalize it. And we get sine is equal to -5 square root 34 over 34. Cosine. X over r. Essentially, we do the same thing, multiply the top and bottom by square root 34, and we should get -3 square root 34 over 34. Tangent. Y divided by x, which is 5/3. That's only 3, however. We need all 6. So let's find the remaining 3. Cosecant is the reciprocal of sine. I forgot to mark my angle as this guy here. So cosecant is the reciprocal, so I flip this guy. It's going to be square root 34 over -5. Secant is the reciprocal of cosine, So it's going to be square root 34 over negative 3. The last one, cotangent. It's going to be the reciprocal, so it's 3 over 5. And there's all 6 trig ratios.